Alright. Okay, using identities to find sine of theta given that cosine of negative. Okay, so the first thing is this is cosine of negative theta. So this is using the identities that we have memorized, not so the identities that you have to have memorized are the reciprocal identities like sine and cosecant, cosine and secant, those. The quotient identities like tangent is sine over cosine. And then the Pythagorean identities, sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, those. So that's the identity we're going to be using. So the identity I'm going to be using is sine squared theta, or alpha, plus cosine squared alpha equals 1. That's the identity I'm going to use. But the other identity I need, the other identity I need is when I have even and odd functions. So if you have a negative inside here, I need to know what to do with it. When I have cosine of negative alpha, I can just take the negative off. If I had sine of negative alpha, I would have to change this to a negative. But cosine of negative anything, it just stays like it is. So that's the first thing I'm going to do, just write it as cosine regular alpha, positive alpha, is 4/7. And then tangent being less than 0, this is just telling me what quadrant I'm in. So if cosine is positive and tangent is negative, what quadrant am I in?
Wait, so you said tangent?
Tangent's negative because it's less than 0, but cosine is positive. Quadrant 4. So when I'm done, I'm just going to make sure all my signs are correct. So because I'm going to be in quadrant 4. All right, so now I am using this identity because they told me I had to use an identity. Otherwise, I would just build a triangle. But since they told me I had to use an identity, I'm plugging into this identity and I'm looking for sine. So sine squared alpha plus cosine squared alpha. Well, I know cosine is 4/7. So I'm just going to put in 4/7 instead of cosine and square it.
One bad hole, literally all bad holes. I don't think it counts.
And then at this point, now it's just arithmetic. So and now I'm going to subtract 16/49 from both sides. So I get 33/49. But that's sine squared theta, and I need just sine theta, or oh, that's alpha, but I just need sine alpha, so I'm going to take the square root of both sides. And that'll give me sine of alpha. And that square root sign goes all the way down to the bottom. So I need to take the square root of the top and the square root of the bottom. Luckily for me, 49 is a perfect square, so that gives me 7 on bottom. Yes. Now, this is where I have to remember I'm in quadrant 4, though. And sine in quadrant 4 is negative. Because when you take a square root, there's both a positive and a negative answer. So I just need the negative answer since I'm in quadrant 4. Okay. All right, so this one's really similar. They told me I'm in quadrant 4, and I've got tangent. I need to use identity, so I'm going to use multiple identities to find all 5 of the trig functions that are left. So the easiest one is to just flip tangent over. If I flip it over, what am I getting? Yeah, cotan. So cotangent of theta is going to be negative 7/2. So there's one of the 5. Then I think probably the next easiest one to find is to use my Pythagorean identity for tangent. So my tangent Pythagorean identity looks like this. So if I use this identity, I'm going to be finding secant. So since I know tangent, I'll just plug it in.
It's, I don't, it's just this course, I hate this course. This course is horrible. This course is horrible.
Then do we square?
Okay, what is that?
Negative positive.
Yep.
This course is the worst course.
Do you have to like, I think you have to reach,
Play me in a different course, see what happens.
I'm pretty sure I saw something about that.
Eliminate the course. Yeah, because of the course, the water moved.
So just a lot like the one above it, I've got secant squared now, so I just have to take the square root.
Final score plus 8, plus 27, and round 2.
And again, 49 is a perfect square, but 53 is not. 53 is prime, so I can just do 53 over 7 equals secant theta. Now,
Is it
in quadrant, yeah, we need to know if it's positive or negative. Well, I'm in quadrant 4, and secant goes with cosine, and cosine is positive, so secant's going to be positive. And because I have secant, I can flip it over and get cosine. So 7 over square root 53 is going to be cosine. But of course, I have to fix that. I can't leave it. So I get 7 square root 53 over 53. And then once I have cosine, I can use the Pythagorean identity for cosine to find sine. So I'm using sine squared theta plus cosine squared theta equals 1. Now, when you do this one, make your life easier and use the one before you rationalized it, because I'm going to square it anyway, which will get rid of the radical. And then it's just less, the numbers are smaller. It's just less to mess with. So I'm looking for sine squared. So I'm just going to write sine squared. And then I'm going to use 7 over square root 53. I have to square that.
I just hit the rock, and it bounced back.
So if I square that, I get 49 over 53. And now I'm just going to subtract 49 53rds.
What's up? That's my first. No, we had to bring it. Did I show you? That means I didn't want to show you.
Alright, take the square root of both sides.
Doing the same dudes?
This time the top is a perfect square and the bottom is not. So I get 2 over square root 53, which I have to rationalize.
It's negative, right?
It will be negative. So I get 2 square root 53 over 53, because this is sine, it's negative. And then the only other one I'm missing is cosecant. And I can just take the original sign I got before I rationalized it and flip it over. And it'll also be negative because we're in quadrant 4.